Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So NCERT Exercise 2.1, two charges 5 into 10 is power minus 8 coulomb and minus 3 into 10 is power minus 8 coulomb are located 16 centimeter apart. At what point or points on the line joining the two charges in the electrostatic potential 0? Take the potential at infinity to be 0. So we have to find a point or points, more than one points, on the line joining the two charges, these two charges where electric potential due to these both charges is 0. So we have to take the potential at infinity to be 0. This is the reference that we are taking potential at infinity to be 0. Okay, so I will give you some time to think about it. So this is the question and the answer is 40 centimeter. Solution. Okay, there are two charges. One charge is Q1 equal to 5 into 10 is power minus 8 coulomb and Q2 is equal to minus 3 into 10 is power minus 8 coulomb. Distance between the two charges D equal to 16 centimeter. By converting it to SI unit, meter, 0.16 meter. Consider a point P on the line joining the two charges as shown in the figure. So here is the figure. So this is Q1 charge placed at this point and this Q1 is equal to 5 into 10 is power minus 8 coulomb, positive charge. This Q2 charge is negative charge, minus 3 into 10 is power minus 8 coulomb. And here is the point P. So now we will take two cases. Okay, so first case is that P lies between these two charges and another case is P lies beyond this Q2 charge, means this P doesn't lie between these two charges, but in this case this P can't be on the left side of Q1 because Q1 has larger magnitude and Q2 has smaller magnitude. Due to larger magnitude of Q1, this zero potential will be between Q1 and Q2 or beyond this Q2. Okay, so distance between the two charges D equal to 16 centimeter and consider a point P on the line joining the two charges as shown in the given figure, and this P point is between Q1 and Q2 at a distance R from the Q1 charge. So now this P point is from distance R from Q1 and from Q2. What is the distance of this P point? D minus R. So R is the distance of point P from charge Q1. Let the electric potential V at point P to be 0. Potential at point P is the sum of potential caused by charges Q1 and Q2. So potential at point P is the sum of potential caused by both the charges, by this positive charge and by this negative charge. It is a net effect, net potential at this point due to this both charges. Okay, so let's suppose firstly V, that potential at P point due to both charges is this Q1 by 4 pi epsilon naught and the distance of P point from Q1 is R, plus Q2 upon 4 pi epsilon naught and the distance of point P from the Q2 charge is D minus R, and the sum of these two potential on P point is equal to V. Now we want to find the P point where potential due to both charges is 0. So put this V equal to 0, where epsilon naught equal to permittivity of free space. For V equal to 0, which is required in the question, equation 1 reduces to this thing. Q1 equal to Q1 by 4 pi epsilon naught R equal to minus Q2 upon 4 pi epsilon naught D minus R. So after solving, Q1 by R equal to minus Q2 by D minus R, put it as second equation. So after putting the values of Q1, Q2 and D, and after solving, 0.16 by R minus 1 equal to 3 by 5, and after solving it, we will get R equal to 0.1 meter, which is equal to 10 centimeter. So R, the distance of the point, so P from the Q1 charge is 10 centimeter. So R is the distance of P point from first charge Q1. So P point is at a distance of 10 centimeter from Q1, and it is between the both charges, because the separation between both charges is 16 centimeter. So it is at 10 centimeter because so it is between the both charges at 10 centimeter from the Q1 and at 6 centimeter from Q2. Therefore potential is 0 at distance of 10 centimeter from the positive charge between the charges. Now we will take second case. Suppose point P is outside the system of two charges. So now second case is point P is outside the system of two charges at a distance S from the negative charge, where potential is 0 as shown in the following figure. So this is the diagram. Now this is Q1 charge, this is Q2 charge. The distance between these both charges is D. And now P point is outside the system, beyond this Q2. So P point is here. So the distance of P point from Q1 charge is S. For this arrangement, potential is given by, now this P point is having distance from Q1 charge S, and from this Q2 charge is S minus D. So for this arrangement, net potential at P point is equal to Q1 by 4 pi epsilon naught, and the distance of this P point from Q1 is S, plus Q2 upon 4 pi epsilon naught, and the distance of this P point from this Q2 charge is S minus D. Put it as third equation. Now for V equal to 0, which is required in this question, equation third reduces to Q1 by 4 pi epsilon naught S equal to minus Q2 by 4 pi epsilon naught S minus D. Put it as fourth equation. Now after that you will put the values of Q1 and Q2 and this D. Q1 by S equal to minus Q by Q2 by S minus D from equation 4. Now put the values of Q1, Q2 and D. After putting the values, now solve this. So 1 minus 0.16 upon S equal to 3 by 5. 0.16 upon S equal to 2 by 5. And from here S equal to 0.4 meter equal to 40 centimeter. So S is equal to 40 centimeter. So there are 2 points where potential due to both charges is 0. So first point is at the distance of 10 centimeter from Q1 charge, and second point is at distance 40 centimeter from the Q1 charge. So these are 2 points where potential due to both charges is 0. Therefore the potential is 0 at a distance of 40 centimeter from positive charge outside the system of charges. So inside the system of charges, the point is at 10 centimeter from Q1. Outside the system of charges, point is at 40 centimeter from the positive charge. Next question, NCERT Exercise 2.2. A regular hexagon of side 10 centimeter has a charge 5 microcoulomb at each of its vertices. Calculate the potential at the center of hexagon. There is a regular hexagon, so which is of side 10 centimeter and has a charge 5 microcoulomb at each of its vertices. So you have to calculate the potential at the center of the hexagon. So I will give you some time to rethink about it. So this is the question. Answer is 2.7 into 10 to the power 6 volt. And the solution is, the given figure shows 6 equal amount of charges Q at the vertices of a regular hexagon. So this is the hexagon A, B, C, D, E, F, and on each vertices of hexagon there is a plus Q charge present. So this is the center of the hexagon and this is B point, and the distance from this vertex is one vertex from the center of the hexagon is D, where charge Q equal to 5 microcoulomb, 5 into 10 to the power minus 6 coulomb. Side of hexagon L equal to AB equal to BC equal to CD equal to DE equal to EF equal to FA equal to 10 centimeter. So all the sides of the hexagon are equal because it is regular hexagon. It is given in the question. Distance of each vertex from the center O. So distance of each vertex from the center is also 10 centimeter because it is regular hexagon, and the angle subtended by one side on the center of the hexagon is 60 degree. So it is equilateral triangle. Okay, so it is if one vertex will subtend an angle on the center of the hexagon, then it will be 60 degree angle, and this is equilateral triangle. So this side is 10 centimeter and this side, the distance from vertex to the center is also 10 centimeter. Okay, so again this diagram, electric potential at point O due to this all 6 charges is equal to 6 into Q upon 4 pi epsilon naught D. Okay, so due to 1 charge is Q by 4 pi epsilon naught D. Due to 6 charges is 6 into Q upon 4 pi epsilon naught D, where epsilon naught is the permittivity of free space. So 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton per coulomb square per meter square, and potential here is 6 into 9 into 10 to the power 9 into 5 into 10 to the power minus 6 upon 0.1, which is D, 10 centimeter, 0.1 meter. And after solving, we will get potential at O point at the center of the hexagon to be 2.7 into 10 to the power 6 volt. Therefore, the potential at the center of the hexagon is 2.7 into 10 to the power 6 volt. So NCERT exercise 2.3, two charges 2 microcoulomb and minus 2 microcoulomb are placed at points A and B 6 centimeter apart. So two charges of equal magnitude but different polarity are placed at points A and B 6 centimeter apart. Identify an equipotential surface on the system. So you have to identify any equipotential surface of the system. What is equipotential surface? Where potential remains same. The surface on which potential remains same between any 2 points. So you have to identify one equipotential surface. What is the direction of the electric field at every point on this surface? So firstly, identify the equipotential surface. Now identify the direction of electric field at any point on this surface. So I will give you some time to think about it. So here is the question, and answer is for A is on which potential is same everywhere. So equipotential surface is surface on which potential is same everywhere, and what is the direction of electric field at every point on the surface is normal to the plane. As we have discussed in the theory section, that direction of electric field at any point on equipotential surface is perpendicular to it. So solution, the situation is represented in the given figure. So this is the parallel, this is the sheet plate which is at midpoint of this both charges and perpendicular to this line AB. So this is the equipotential surface for a dipole. We know that both the charges have equal magnitude and different polarity. So these two charges will form a dipole, and we know that for dipole there is a equatorial line or equatorial plane where potential is 0 at any point. For dipole there is a equatorial plane which is at midpoint of the dipole and passing through the midpoint and perpendicular to this line AB, where potential due to both the charges is 0 everywhere. So this is considered as equipotential surface where potential is 0 everywhere. Okay, so this plate which is perpendicular to AB is considered as equipotential surface. And equipotential surface is the plane or the contact points in space on which potential is same everywhere. This plane is normal to AB. So this plane is normal to AB, and this plane is located at the midpoint of the line AB because the magnitude of charges is the same. That's why it is located at midpoint of the charges. And the second thing, the direction of electric field at every point on this surface is normal to the plane in the direction of AB. Okay, so electric field, direction of electric field here is direction of electric field at every point on this surface is normal to the plane in the direction of AB. So electric field is from A to B, and the direction of electric field at this surface is perpendicular to this surface from A to B. Okay. Next question. A spherical conductor of radius 12 cm has a charge of 1.6 into 10 to the power minus 7 coulomb distributed uniformly on its surface. What is the electric field inside the surface, inside the sphere, just outside the sphere, and C part is at a point 18 cm from the center of the sphere. So a spherical conductor of radius 12 cm is charged with this charge. So we have to find the three cases and at 3 points where we have to find the electric field. So inside the sphere, second just outside means, so they have twisted the words, just outside means on the surface. Just outside the sphere means on the surface, and at a point 18 cm. So its radius is 12 cm. So 18 cm is outside point. So outside the sphere. So I will give you some time. This is the question, and answer is, the answer for A part is 0, answer for B part is 10 to the power 5 Newton per coulomb, and answer for C part is 4.4 into 10 to the power 4 Newton per coulomb. So how this answer is coming? Let's see. Solution. Radius of spherical conductor is 12 cm, and after converting it to SI unit, 0.12 meter. Charge is uniformly distributed over the conductor. So Q is equal to 1.6 into 10 to the power minus 7 coulomb. So it is uniformly distributed over the conductor. So it is given in the question. So the A part, we know that electric field inside a charged sphere is 0 always if the sphere is conductor. So electric field inside a spherical conductor is 0 always. This is because if there is a field inside the conductor, then charges will move to neutralize it. So if there will a field that exists on the surface or inside, this will cause the movement of the charges within. So charges will redistribute and distribute in such a form that they will make electric field inside the conductor 0 in a static condition. Okay, so electric field inside a spherical conductor is always 0. So B point, just outside the surface, which means just outside the sphere, which means on the surface of sphere. So electric field E just outside the conductor is given by the relation E equal to Q by 4 pi epsilon naught R square. So at the surface, we will take this R as 12 centimeter, where epsilon naught equal to permittivity of free space, and 1 by 4 pi epsilon naught, we know the value of this constant, 9 into 10 to the power 9 Newton meter square per Coulomb square. E equal to 1.6 into 10 to the power minus 7 into 9 into 10 to the power minus 9 upon 0.12 raised to power 2. So after putting all the values, we will get 10 to the power 5 Newton per Coulomb. So the electric field just outside the sphere, or we can say on the surface of the sphere, is 10 to the power 5 Newton per Coulomb. Therefore electric field just outside the sphere is 10 to the power 5 Newton per Coulomb. Okay, C part. Electric field at a point 18 meter from the center of the sphere E1 is equal to E1. So electric field at a point 18 centimeter from the center of the sphere E1. So distance of the point from the center is equal to 18 centimeter. Now it is outside point. Okay, so outside the sphere, which is equal to 0.18 meter. So E1 is equal to Q by 4 pi epsilon naught D square. D is the distance of the outside point from the center of the sphere, which is 18 centimeter, or we can say 0.18 meter, or we can say in scientific notations 18 into 10 to the power minus 2 meter. So after putting the values of Q, and D and this constant 1 by 4 pi epsilon naught, you will get the electric field at a point 18 centimeter from the center of the sphere is 4.4 into 10 to the power 4 Newton per Coulomb. Therefore the electric field at a point 18 centimeter from the center of the sphere is 4.4 into 10 to the power 4 Newton per Coulomb. Next question. A parallel plate capacitor with air between the plates has a capacitance 8 picofarad. 1 picofarad is 10 to the power minus 12 farad. What will be the capacitance if the distance between the plates is reduced by half? Okay, so initially there is air between the plates of the capacitor with capacitance this. Now distance between the plates is reduced by half, and the space between them is filled with the substance of dielectric constant 6. Okay, now you will have to find the new capacitance. So I will give you some time to think. So here is the question, and the answer is 96 picofarad. So this is the new capacitance. So solution, capacitance between the parallel plates of the capacitor is 8 picofarad initially, when there is air between the plates and distance between them is D. So initially distance between the parallel plate was d and it was filled with air. Dielectric constant of air is K equal to 1. For air, dielectric constant is 1. So the capacitance initially K epsilon naught A upon D. K is 1 here for air. So epsilon naught A upon D is the initial capacitance of the capacitor, which is equal to 8 picofarad. Put it as equation 1, where A equal to area of each plate, epsilon naught equal to permittivity of free space. A is the area of each plate and epsilon naught is permittivity of free space. If distance between the plates is reduced to half, now what is asked in the question? Now when we reduce the distance between the plates to half, that is d becomes d by 2. So new distance between the plates d dash equal to d by 2. And dielectric constant of the substance filled in between the plates is of dielectric constant 6. So new dielectric constant in initial condition, what was the dielectric between the plates is air. And dielectric constant of air is 1. Now dielectric constant of other medium which is inserted now K dash equal to 6. Now hence capacitance of the capacitor becomes, now put this value in the formula of capacitance. So C dash equal to K dash epsilon naught A upon D dash. So K dash now here is 6 and D dash is D by 2. Okay, put it as equation 2. So now taking ratios of equation 1 and 2, we obtain C dash equal to 2 into 6C and it will become 12C. What was the value of C? 8 picofarad initially. So now the new capacitance will be 96 picofarad. Therefore the capacitance between the plates is 96 picofarad is the new capacitance when distance between them the plates of capacitor is halved and there is a dielectric with dielectric constant 6 is inserted between the plates. So exercise 2.6, 3 capacitors each of capacitance 9 picofarad are connected in series. So A part, what is the total capacitance of the combination? So 3 capacitors of 9 picofarad are connected in series. So firstly we have to find the equivalent capacitance of the combination. Then after, what is the potential difference across each capacitor if the combination is connected to 120 volt. If the combination of 3 capacitors is connected across the 120 volt supply, then potential difference across each capacitor should be found. So I will give you some time. So this is the question again, and the answer is capacitance of combination will be 3 microfarad and potential difference across each capacitor is 40 volt. So now let us see solution. Capacitance of each of the 3 capacitor is 9 picofarad. So capacitance of each capacitor is given 9 picofarad. Now they are connected in series. So equivalent capacitance of the combination of the capacitors is given by the relation. So now when capacitors are in series, how we find the equivalent capacitance? C dash, we will find it as 1 by C dash equal to 1 by C1 plus 1 by C2 plus 1 by C3. So 1 by C dash equal to 1 by C plus 1 by C plus 1 by C, because capacitance of all the 3 capacitors is same. So we are now using C1, C2, C3 as CCC. Okay. So all the capacitance is equal to 9 picofarad. So 999. So after solving, we will get 1 by 3. 1 by C dash equal to 1 by 3. So C dash will be 3 microfarad. This is the equivalent capacitance of the combination. Now A part is finished. Now B part. What is the potential difference across each capacitor? Therefore, total capacitance of combination is 3 microfarad. Now B, supply voltage is 120 volt. Okay. Potential difference V dash across each capacitor is equal to 1/3 of the supply voltage. In this case, capacitors are identical with equal capacitances. So potential difference will distribute equally among all the capacitors. But if there are non-identical capacitors, so you have to find the charge in the circuit first. Then after you can find the potential difference across each capacitor by the formula Q equal to CV. Okay, so from there, this formula you can find the potential difference across each capacitor by V equal to Q by C. Okay, so if there are capacitors that are non-identical, you have to find the charge first. Then you can find the potential across each capacitor. Now the charge, they are identical capacitors, so potential difference will distribute equally among all the capacitors. So V dash equal to V by 3 equal to 120 by 3 equal to 40 volt. So therefore the potential difference across each capacitor is 40 volt. Next question, exercise 2.7. 3 capacitors of capacitances 2 picofarad, 3 picofarad and 4 picofarad are connected in parallel. Now the capacitors are non-identical and they are connected in parallel. What is the total capacitance of the combination? You have to find, and after that determine the charge on each capacitor if the combination is connected to 100 volt supply. Okay, so I will give you some time to think about it. So this is the question. So answer for A is 9 picofarad is the equivalent capacitance in parallel combination, and charge on each capacitor is, charge on first capacitor is 2 into 10 to the power minus 10 coulomb, 3 into 10 to the power minus 10 coulomb, and charge on third capacitor is 4 into 10 to the power minus 10 coulomb. So let's see the solution. So we know that capacitance of the given capacitors are C1 equal to 2 picofarad, C2 equal to 3 picofarad and C3 equal to 4 picofarad. So equivalent capacitance for parallel combination is just the sum of all the capacitances. So for parallel combination of the capacitors, equivalent capacitance C dash is given by the algebraic sum. So C dash equal to 2 plus 3 plus 4 equal to 9 picofarad. Okay, this is simple. Therefore, total capacitance of the combination is 9 picofarad. Now the second part, determine the charge on each capacitor if the combination is connected to 100 volt supply. Supply voltage is 100 volt. The voltage through all 3 capacitors is same because they are connected in parallel. So voltage across all the 3 capacitors will be same. V equal to 100 volt. And their capacitance is also given. Individual capacitance is also given. We can find the charge on each capacitor by the formula Q equal to CV. So V is same for all the capacitor, but C is different. So Q will be different for each capacitor. So charge on a capacitor of capacitance C and potential difference V is given by the relation Q equal to VC. Put it as one first equation. For C 2 picofarad, for first capacitor of 2 picofarad, charge on this capacitor will be VC. V is same for all capacitors, 100 volt. And for this capacitor 2 picofarad, C is 2. So charge on this capacitor is 200 picofarad, which is 2 into 10 to the power minus 10 coulomb. For C equal to 3 picofarad. Now for this capacitor, charge will be equal to VC, equal to 100 into the capacitance of this capacitor 3, equal to 300 pico coulomb, equal to 3 into 10 to the power minus 10 coulomb. Similarly, for capacitor 4 picofarad, charge will be Vc equal to 100 into 4, 200 picocoulomb equal to 4 into 10 to the power minus 10 coulomb. So charge on these 3 capacitor will be 200 picocoulomb, 300 picocoulomb and 200 picocoulomb. Pico means 10 to the power minus 12. Okay. So this is the charge on all 3 capacitors. So next question, exercise 2.8. In a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 to the power minus 3 meter square. And the distance between the plates is 3 mm. So this is A given area and this is D given 3 millimeter. Calculate the capacitance of the capacitor. And there is air between the plates initially. Okay. If this capacitor is connected to 100 volt supply. Okay. Now V is given. If this capacitor is connected to 100 volt supply, what is the charge on each plate of the capacitor? So you have to find the charge on each plate of the capacitor. So I will give you some time to think about it. So this is question and the answer is 17.71 picofarad is the capacitance and 1.771 into 10 to the power minus 9 coulomb is the charge on each plate. Solution. Area of each plate is given A equal to 6 into 10 to the power minus 3 meter square. Also the distance of separation between the plates is given D equal to 3 millimeter equal to 3 into 10 to the power minus 3 meter. Supply voltage is also given V equal to 100 volt. Now capacitance of parallel plate capacitor is given by C equal to epsilon naught A upon D. A is given, D is given and we know the value of epsilon naught. So epsilon naught is equal to permittivity of free space which is equal to 8.854 into 10 to the power minus 12 Newton minus 1 meter minus 2 coulomb minus 2. Okay. C equal to 8.854 into 10 to the power minus 12 into 6 into 10 to the power minus 3 by 3 into 10 to the power minus 3 using equation 1. So after solving this you will get 17.71 into 10 to the power minus 12 farad which is equal to 17.71 picofarad. This term 10 to the power minus 12 is called pico. Potential V is related with the charge Q as capacitance C as V equal to Q by C. Now we know that what is the capacitance of the capacitor and we know the potential supply. What is the supply voltage? 100 volt. So after putting C and V, we will get the charge on each plate of the capacitor which is equal to 100 into 10, 17.71 into 10 to the power minus 12 which is equal to 1.771 into 10 to the power minus 9 coulomb. So this is the charge on each plate of the capacitor. So firstly we have found the capacitance of parallel plate capacitor, then we have found the charge and voltage supply is given and capacitance we have calculated. We can find the charge on each plate of the capacitor. So therefore capacitance of capacitor is 17.71 picofarad and charge on each plate is 1.771 into 10 to the power minus 9 coulomb. So exercise 2.9, explain what would happen if in the capacitor given in the exercise 2.8 in the last exercise a 3 millimeter thick mica sheet of dielectric constant 6 were inserted between the plates. So in exercise 2.8 we calculate the capacitance with air between the plates. Now we are inserting a 3 millimeter thick mica sheet of dielectric constant 6. Now the separation between the plate was also in exercise 2.8 3 millimeter and the thickness of mica sheet is also 3 millimeter, means it is fully inserted between the plates. So firstly we have to find while the voltage supply remains connected, then you have to find what happens. What happens to the capacitance and charge while the voltage supply remains connected. And second case, after the supply was disconnected, then what happened to the capacitance and charge stored. Okay, so this is the exercise 2.8 that we have done previously. So I will give you some time to think about it. So this is the question, and answer is new capacitance is 106 picofarad and potential is equal to 16.7 volt. Solution. Dielectric constant of the mica sheet is given K equal to 6. Initial capacitance was also we calculated in exercise 2.8. Initial capacitance with air between its plates we calculated 1.771 into 10 to the power minus 11 farad. Now new capacitance will be, because the mica sheet is completely inserted, we know that the new capacitance with dielectric between the plates is equal to K into C. C is the capacitance with air between its plates. So K into C, C we calculated in exercise 2.8 and multiply it with K6, we will get 106 picofarad. So new capacitance will be 106 picofarad when we insert a thick mica sheet and also voltage supply remains connected. Either voltage supply remains connected or disconnected, capacitance will increase in both cases. Either supply was connected or disconnected, capacitance will increase when we insert mica sheet. So supply voltage V equal to 100 volt. New charge. What is the new charge on the capacitor now? So Q dash equal to C dash V. Since the voltage supply is connected, so potential difference will remain same, 100 volt, because the battery is connected. So what is changed? Capacitance is changed. So due to change in capacitance and voltage remain constant, Q charge on the capacitor will change, which is equal to 6 into 1.771 into 10 to the power minus 9, which is equal to 1.06 into 10 to the power minus 8. So potential across plates remain same because battery is connected. Dielectric constant K is equal to 6. Initial capacitance was this when there was air between the plates. And new capacitance will become 106 picofarad. This is the A part. What is changed in A part? Due to insertion of mica sheet, and when voltage supply remained connected, capacitance changed and charge changed. Capacitance will change in both cases. Either voltage supply remains connected or disconnected. But additionally, what will change? We will see according to the case. So in first case, capacitance changed and charge also changed. Now we will see in second case, if supply voltage is removed, B part, then there will be no effect on the amount of charge on the plates. If supply voltage we disconnected, so there will not be any effect on the amount of charge because charges are stored on the capacitor. We disconnected the battery, but charges will not get reduced because according to conservation of charge, charge will remain as it is. And we have disconnected the battery, so charges will not increase, not decrease. They will remain same. Okay, so there will no effect on the amount of charges on the plates if voltage is removed. So charge will remain 1.771 into 10 to the power minus 9 coulomb. Charge will not increase and not decrease. Charge will not change. Potential across the plates is given by, now capacitance, I already mentioned that capacitance will change. Either battery is connected or disconnected. So we will use C dash here, which is increased capacitance due to insertion of mica sheet. So but in second case, charge is constant. So what V dash will be? V dash will be Q upon C dash. After putting the value of Q and C dash, we will get 16.7 volt, which is the potential difference across the capacitor plate when the supply voltage is disconnected. Now, what you can conclude from both these cases, when supply voltage remain connected, charge and capacitance will change. When supply voltage was disconnected, voltage and capacitance will change. Okay, capacitance always increases, but when voltage remain connected, charge increases. When voltage is disconnected, voltage decreases. Got it? Next question. A 12 picofarad capacitor is connected to 50 volt battery. How much electrostatic energy is stored in the capacitor? So this is simple question. I will give you some time. So this is the question, and answer is 1.5 into 10 to the power minus 8 joule. Solution. Capacitor of the capacitance C equal to 12 microfarad. Okay, 12 into 10 to the power minus 12 farad, and potential difference is given V equal to 50 volt. Electrostatic energy stored in the capacitor is given by relation U equal to half CV square. Okay, so U, or we can say E. Okay, so E equal to half CV square. Electrostatic energy stored in the capacitor is given by the relation E equal to half CV square. So 12 microfarad is the C. 12 picofarad is the C. 12 into 10 to the power minus 12 into voltage square, 50 square, 1.5 into 10 to the power minus 8 joule. So therefore the electrostatic energy stored in the capacitor is 1.5 into 10 to the power minus 8 joule. Thank you.